Hi, I'm Mary, and this is another Magical Math Moment. This is the third video in the series of 3 in regard to graphing quadratics in Vertex form. This is designed for Algebra 1 students who are seeing this topic for the first time. So we're going to put all of the parameters a, h, and k together. All right, let's get to it. Here is the Vertex form of a quadratic function. Y is equal to a times the quantity x minus h squared plus k. The vertex can be found by looking at the equation and putting hk in a coordinate pair. The axis of symmetry is simply the line x equals h. Remember, this is the vertical line that passes through the vertex. So we have our parent function over here of y equals x squared. We're also just going to throw the axis of symmetry in here for you so you can see what that's like. All right, and our vertex for this obviously is 0, 0. You can watch the previous videos to talk a little bit about how I got those points, all right? I'd like to get into a couple of transformations with you so you can see how these things move. Let's go ahead and start with just shifting the vertex to begin with. So we're gonna look at y equals x minus 3, the quantity squared, plus 1. Okay, the first thing I wanna do is identify my a, h, and k values. In this case, there's no number out front, so it's assumed a is 1. H is the opposite of what it appears, 3. K is exactly how it appears, 1. So I know from this information that my vertex will be the point 3, 1. The transformation is that we are moving right 1 and up, right 3 and up 1. All right. Let's see what this graph looks like. I think I'm going to do it on the same grid so that you can see how it looks in terms of the shift. So I'm going to go over to 3, 1, and make my dot. The pattern is still the same in terms of the a, so up 1 over 1, and then up 3 over 1. I guess I need to put another little guy over there. Okay. So then here is that function. So nothing has happened to the width of the graph, as you can see, although it's not a perfect graph since I'm not on graph paper, but you can see that the vertex has shifted from 0, 0 over 3 and up 1 to its new spot at 3, 1. So that's pretty much all you have to do when you're putting these things together. Now you can also look at some where the a value changes a little bit. So what if we have something like y equals 2 times the quantity x minus, or let's do a plus this time, x plus 3 squared, how about minus 4? So if I'm gonna do this over here, I'm gonna add in a couple of more, so I need to be able to go down 4, a couple more little hash marks on our graph so we can see what's happening. So the first thing I want to do is list out a, which is 2, h, the opposite of what we think, negative 3, and k is exactly how it looks, negative 4. This means that our vertex is negative 3, negative 4. I'm going left 3 and down 4. Okay, let's graph it and see what it looks like. So I'm going over 1, 2, 3, and then down 4. The other thing that's happening with this graph is that I have an a value of 2. That is going to make the graph appear more narrow. It is a vertical stretch. This impacts our pattern in terms of the vertical changes. So normally we're going up 1 over 1. I'm going to multiply this by that a value. So 1 times a. That's going to give, 2 times a is going to give me, oh my gosh, I got that completely backwards. 2 times 1 is 2. So I'm going to go up 2 over 1. It's been a long day, can you tell? So from this point, I'm going up 2 over 1. And I'll do 1 over this way too. And you could see your graph. So this one's a little bit more narrow than what's going on there. Okay. How about one more? Let's see if I can do it without any mistakes. I believe. We'll see how it goes. How about we have y equals -1/2. How about x plus 1, the quantity squared, plus 4. Let's get wild. Okay. So in this one, a is -1/2. The negative is going to reflect over the x-axis. The 1/2 is a vertical shrink. So the graph is going to appear wider as a result. Our h value is the opposite of how it appears, -1. And the k value at the end is exactly how it appears, 4. This means that our vertex is the point, -1, 4. -1 means I'm going left 1. +4 means I'm going up 4. All right, let's plot this thing. I'm gonna go back over to my grid here. Sorry, I'm off the screen with the other stuff. We've got -1, 4, so that's up here. Now this a value is -1/2, so I know it's gonna be opening down. Very similar to this stuff, I would be going down 1/1 with my pattern. However, I'm going to be looking at that 1/2 and multiplying it by 1. So I'm going to be going down 1/2 and over 1. All right, so down 1/2 over 1. This is hard to kind of see on here. And then this one will be here. I can repeat this process. So normally I would go down 3 over 1, but 3 times 1/2 is 3/2 or 1/2. So that means I'm going to go down another 1/2 and over 1. And then I'm going to have the symmetry over here as well. So here is my -1/2 x squared. You might notice that the pattern here is going from the vertex down 2 over 2. Sometimes students don't like to include these points and they like to go right to this. I mean, it makes sense, right? Who wants to try to do a half if you could just do down 2 over 2? So that's something to keep in mind when you've got an a value of -1/2 like that. All right, I'm gonna give you one to try and let's see how you do, all right? How about y equals, let's do 3 times the quantity x minus 4 squared plus 5. Go ahead, pause the video and see if you can do it. Okay, hopefully you've had enough time to work this out. We want to start by listing out our a, h, and k values. All right, there we go. So a is 3, h is the opposite of what it appears for, k is exactly how it appears. The vertex this time is the point 4, 5, which is kind of up there, in the first quadrant. So we're going to be going, let's see, left 4, up 5. The 3 is going to give a vertical stretch. So this graph is going to appear more narrow. Did you get that part so far? I hope so. Let's see, I gotta kind of make sure I got enough space here. All right, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so we have some points labeled here. So I'm gonna go over to 4, 5, 4, 5, there we are. Now normally I'm going up 1, but a is 3 this time. So instead of going up 1, I'm going up 3. 1, 2, 3 over 1. There we go. So we're gonna go ahead and draw our graph. Now because of the way I have this spaced, it doesn't really look that much more narrow. But when you think about how a normal graph would look, if I was doing this, it would be like so. So I just want to show you that real quick. So that would be the graph of y equals x minus 4, the quantity squared plus 5, where a is 1, and we do the normal pattern, up 1 over 1. up 3 over 1. My grid, I'm a little off from my grid here because I'm not on graph paper, but you get the idea of how the blue graph is now more narrow. I hope that this information has been helpful for you, and if this has been good for you, please feel free to share with a classmate, and like and subscribe for more math content. Thank you so much for watching, and I'll see you next time. Bye.